Hello dear students. In this lecture we are going to see numericals on welded joint. Basically in this lecture we are going to see numericals on fillet and butt weld. Those who are those questions which are asked in previous year GATE examination. Now see, first question is on fillet weld. In this lecture we are going to see 4 questions. All are either on fillet weld or on butt weld. So first of all, understand what is the fillet and what is the butt weld. Right. First of all, we will understand fillet weld. See, if two plates are connected, here you can see this is a one plate. Here there is a one plate and there is a other plate. These two plates are connected with the help of welding over here. Right. At this location there is a welding. You can see here there is a, and here at this location welding is provided. And such type of welding is called fillet weld. Means if one plate is kept over the other plate, then such type of weld is called fillet weld. Now let us understand the fillet weld. Let us say there is one plate. This is a one plate having some thickness, right? And there is one more plate like this. There is a one more plate like this. And these two plates we need to connect with the help of fillet weld, right? If one plate is kept over the other plate, then such type of joint is called fillet weld. You can see here, these are the two plates. Let us say here, the plate thickness we are considering as a S. Plate thickness we are considering as a S, right? Thickness of plate is S, which is called leg size also. S is plate thickness or also called leg size. It is also called as leg size. Right. Now, here my target is to join these two plates with the help of fillet weld. Now, at this location, see, at this location we will provide welding. At this location we will provide welding. The red color you will see, it is a welding provided. Right. This is a welding provided. Now, this is called fillet weld. Fillet weld. If one plate is joined by keeping over the other plate, then such type of welding is called fillet weld. And the thickness of plate is considered as leg size or plate thickness. We can say plate thickness also. Now let us go for the solution. If I see these plates, the plates, if I draw the 2D view of these plates, then plates will look like this. This is a one plate, right? And one plate is below this plate. Plates are kept one over the other, right? And welding is provided at this location. Welding is provided at this location. This is called parallel fillet. Here, see, this is the axis and load is passing through the axis. The load applied on the plate is P. Here you can see P is applied load. Applied load on the plates like this. P is applied load here. Now you can see here the welding and the load are parallel to each other. Here you can see the welding and load is parallel to each other. Therefore, this is called parallel fillet weld. This is parallel fillet weld. Parallel fillet weld. And if welding and load is perpendicular to each other, let us say if I do welding over here, like this, at this location, if I provide welding. Now this welding, can you see this welding is perpendicular to the load axis? Therefore, this welding is called transverse fillet weld. Here, this is transverse fillet weld. Transverse fillet weld. Right. If welding and load are perpendicular to each other, then it is called transverse fillet weld. Otherwise, if welding and load are parallel to each other, then it is called parallel fillet weld. And if I see its another view, the another view will look like this. This is the plate 1 of leg size ES, or plate thickness is ES, right? And another plate. Here I am considering leg size for both plate is same, or plate thickness I am considering for both is same, right? Now, and welding is provided at this location. You can see the plates are like this, and for both weld size is yes or thickness is yes, and welding is provided at this location like this. There is a welding, right? It is a welding. Now, our target is to focus on this, right? Our target is to focus on this and design this fillet weld. Now, if I want to design this fillet weld, you can see this section over welding. Here, this portion of welded portion, right? If I zoom this, here I will show you. If I zoom this portion, right? Can you see the leg size for this welding? It is yes, and vertical also yes, right? If I zoom this will be yes, and height will be yes, right? Therefore, it will look like the welded portion will look like here. This is the one plate having plate thickness yes. उसको मैंने जूम किया है, बहुत इनलार्ज किया है, और दूसरी प्लेट भी है. देयर इज वन मोर प्लेट having leg size yes. This dimension is yes, or it is also called plate thickness. Yes is also called plate thickness, and welding is provided here at this location. Welding is provided. This will be yes, this will be yes, right? And welding is done like this. Here you can find this is a welding. Red color is welding, right, between two plates. Now this extra material you can see from this point. These upper points are called toe point. These are called toe point, and here this corner point is called root point. Corner point is called root point. Now, if I join both toe points with straight line, see, actually for this straight line, lower portion is required only. This is the welding. Therefore, this upper portion you can see, this is extra material. This is a human error. This upper portion is human error, which is called reinforcement. It is called reinforcement. It is a human error, right? Therefore, this reinforcement is not considered in design. Remember, my dear students, reinforcement is never considered in the design because it is a human error. Human error hai wo. Then later we are removing this with the help of grinder, right? With the help of grinder, we are removing this reinforcement. Therefore, if you see here, you will find here isosceles triangle. This is a welding. This isosceles triangle is a welding, right? Therefore, if I consider this triangle, see, for welding, height is yes, width is also yes, right? And from here there is a straight line, right? Now this is your welding. Therefore, yes is called leg size for the welding, also called plate thickness. Yes is also plate thickness as well as leg size, right? Can you see here with vertical and horizontal there is definitely 90-degree angle. Here there is definitely 90-degree angle, right? Therefore, because the two sides are same, therefore these two angles must be same. Therefore, this angle will be 45 degree. This angle will be 45 degree, and this angle will be 45 degree. Right? Definitely we can say these angles will be same because it is an isosceles triangle. Right? Now, because of the loads here you have seen, because of this parallel load or this transverse load, if it is transverse fillet weld, then it is a transverse load. If it is a parallel fillet weld, it is a parallel load. Because of this load P here, because of this load P, the weld is going to fail. Now, let us say the failure of this weld, let us say the failure plane of this weld is like this. Let us say this is a failure plane. कोई भी plane हो सकता है, my dear students. The plane can be any. I am assuming this is a failure plane, and failure always starts from the root. Failure always starts from the root, and I am assuming this is a failure plane. Now let us say the thickness of failure plane is T. Here I am considering thickness of failure plane is T. Right. This dimension I am considering as a thickness of failure plane. I will represent with red color. This much dimension I am considering as a thickness. Right. And along the length, here you can see, let us say this is a length of welding. Let us say this is a length of welding L. In previous diagram, you can see here it is a length of welding. Along this length and along this thickness, along this length and along this thickness, the weld is failing. Right. Here thickness T and length L, the weld is failing. Right. Now let us solve for this. Now our main target is to find this thickness T. Here our main target is to find this thickness T. Right. Now let us find this thickness T, because this is very important, my dear student. Many times they are in GATE examination, they are asking question on this only. Right. Now therefore our target is to find this thickness T. Now let us consider triangle. Here if I consider triangle A, B, C. Right. Let us name the points A, B, C, D. Likewise. Now, if I consider triangle A, B, C only. Right. Now, in this triangle, one side is S, other side BC is not known, and AC is we have assumed as a thickness T, along which it is going to fail. Right. Now, if I draw this triangle, here I will draw this triangle. Now, this A to B, here A, B, A to B distance is S, right? And there will be at 45 degree. This angle is definitely 45 degree. We know that this angle is 45 degree. And there will be another point, C point, right? And here this thickness T we are assuming. This thickness T we are assuming for this triangle. Now, in this triangle, use sine rule. Use sine rule. Sine rule also called Lami's theorem. Lami's theorem. And this sine rule or Lami's theorem you are going to learn in engineering mechanics. For this triangle, if I use sine rule or Lami's theorem, then we will get all the sides as well as all the angles. And this sine rule you are going to learn in engineering mechanics. Right. Now, let us assume at A angle is theta. Let us assume at A angle is theta. Here my assumption is at A angle is theta. Therefore at C what will be the angle? Total summation is 180 degree. At C, theta at C will be summation of all the three angles is 180 degree. Therefore it is 180 minus 45 plus theta. School level mathematics. It is a school level mathematics, right? And sine rule says that any side, let us say side S, any side divided by sine of opposite angle. Sine of opposite angle means if I consider side S, then I have to consider angle at C. Then I have to consider angle at C, right? Therefore, side S divided by sine of 180 minus 45 plus theta, right? Is equal to, this ratio is constant. If I consider thickness T, because it is a failure plane, thickness T is a failure plane. If I consider thickness T divided by sine of 45, because opposite angle, thickness, for thickness opposite angle is angle at B, which is 45 degree, right? Therefore thickness T will come, and we know that one rule, again one property, sine 180 minus theta, sine 180 minus theta is nothing but sine theta, is nothing but sine theta. Therefore here we can write S divided by sine 180 minus 45 plus theta, we can write 45 plus theta, sine 45 plus theta is equal to T divided by sine 45, T divided by sine 45, right? Therefore thickness T we can write S divided by sine 45 plus theta into sine 45. This is a thickness T, right? And area of failure is area of failure. Thickness T is a thickness at failure plane, na? Area of failure will be thickness into length of weld. Area of failure will be thickness into length of weld, right? Definitely. Now therefore we have to find this thickness. What will be the thickness when this weld is going to fail? Now here I have derived this much derivation, so I will use this result here. I will use this result. We are going to find this thickness, right? Therefore thickness T is equal to weld leg length or thickness of plate. S is thickness of plate. T is thickness of failure plane. My dear students, T is thickness of failure plane, and S is thickness of plate or weld size, right? Therefore S divided by sine 45 plus theta into sine 45, right? Now we have one more sign property, sine A plus B. We have one more sign rule, that is sine A plus B is nothing but sine A cos B. It is sine A cos B plus cos A sin B. Cos A sin B. This is a sign property, right? Sine A plus B is nothing but sine A cos B plus cos A sin B. Use here. Therefore I can write sine 45 plus theta is equal to sine 45 cos theta plus cos 45 sin theta, right? Therefore, and my dear students, we know that sin 45 is equal to cos 45, sin 45 is equal to cos 45. ये आपको आना चाहिए माय डियर स्टूडेंट्स, ये आपको आना चाहिए. ये सारा बहुत सिंपल मैथमेटिक्स है. एट द एंड अगर इस लेक्चर में आपने फॉर्मूला भी याद रख लिया तो भी कोई दिक्कत नहीं है. इफ यू रिमेंबर फॉर्मूला द एंड रिजल्ट देन आल्सो नो प्रॉब्लम. वी मस्ट नो दैट sin 45 is always equal to cos 45, which is nothing but 1 by root 2. The value is 1 by root 2, right? Therefore here we can say sin 45 plus theta is equal to sin 45 cos theta plus sin theta, because here sin 45 and cos 45 are same. Therefore sin 45 and cos 45 I can take common. Sin 45 cos 45 is nothing but sin 45 only. I can take common. Now let us find the throat thickness, put here. Therefore we can write, put this in throat thickness formula. Therefore we can write here, put in this thickness is nothing but here, instead of sin 45 plus theta, put sin 45 cos theta plus sin theta. Therefore thickness will come S divided by sin 45 in bracket cos theta plus sin theta, right, into sin 45. Therefore sin 45 sin 45 will get cancelled, right? Simply मैं values को put कर रहा हूं दोस्तों यहाँ पे. Therefore thickness will become S divided by sin theta plus cos theta. This will be the thickness, right? Now here this is the thickness, S divided by sin theta plus cos theta, right? Now I am jumping to very important result now here, right? Now what is stress? There will be shear stress because of transverse loads, or because of this in fillet weld there is a failure is assumed because of shear stresses, right? Therefore shear stress is equal to, see, in theory lectures I have explained all these details properly. I am assuming that you have learned these concepts from my theory lectures. These recorded theory lectures you will get in Ekeeda application, right? Only I am here revising these things, right? and the failure is because of shear stresses. Therefore, shear stress is nothing but load divided by area, which is nothing but load divided by area is nothing but shear area, that is T into L. This thickness, throat thickness, failure plane thickness, we have to consider. T is a failure plane thickness that we have to consider, right? Now, therefore, in this case, the failure is always because of the maximum shear stresses. This shear stress will become maximum when this thickness will become minimum. Correct or wrong? Shear stress will become maximum. See here, you can see in the formula, thickness in denominator. As thickness goes on decreasing, shear stress goes on increasing. Thickness decreases means area decreases means shear stress increases. Therefore, the failure will be whenever this thickness is minimum, and this thickness will be minimum when the sin theta plus cos theta becomes maximum. Therefore, this thickness will become minimum when this sin theta plus cos theta becomes maximum, right? And now these basic things you must know. Sin theta plus cos theta is maximum when theta is 45 degree. My dear students, this sin theta plus cos theta becomes maximum when theta becomes 45 degree. You can check. किसी भी एंगल को निकाल के देखो. You can check this. Right, becomes maximum whenever theta is 45 degree. Therefore, we can say sin 45 plus cos 45 is equal to sin 45 is 1 by root 2 plus cos 45 is also 1 by root 2, which is nothing but 2 by root 2, which is again nothing but we can write root 2 into root 2 divided by root 2. 2 को हम लिख सकते हैं ना, root 2 into root 2. Therefore, 1 root 2 will get cancelled. Therefore, sin 45 plus cos 45 you will find under root 2. Sin 45 plus cos 45 you will find under root 2. Right. Therefore, the thickness, minimum thickness you will find S divided by under root 2. Right. The minimum thickness you can put in this formula. Thickness is equal to S divided by sin theta cos theta. Right. You will find S divided by under root 2, which is nothing but it is called throat thickness. This thickness is called throat thickness. And बहुत सारी कॉम्पिटिटिव एग्जाम में थ्रोट थिकनेस पे भी क्वेश्चन पूछा है. व्हाट इज द थ्रोट थिकनेस? Many competitive exams are asking question on finding of throat thickness also. Right. Here I have calculated throat thickness, which is nothing but S divided by root 2 is nothing but throat thickness. Right. Now let us go for the solution. Now, therefore I can write here throat thickness is equal to S divided by root 2. All right. T is throat thickness, and along this thickness there is a failure. We can say along this throat thickness there is a failure, and S is called plate thickness. S is called plate thickness, or also called leg size. It is also called leg size, right, over here. And therefore the maximum shear stress in the component will be applied load divided by throat thickness into length of weld. Therefore, P is applied load. Here we can say P is applied load and EL is weld length. Right. Therefore, we can write the maximum shear stress is equal to P divided by throat thickness is nothing but S by root 2 into L. Right. Therefore, is equal to root 2 will go up, root 2 P divided by S L. Right. Now, therefore, this load, the maximum load carrying capacity of the plate. Now, this maximum, as per maximum shear stress theory, in theories of failure, you have seen this as per maximum shear stress theory, tau max theory, or also called Gauge theory. As per maximum shear stress theory, also called Gauge theory or Tresca's theory. This maximum shear stress is nothing but shear yield strength divided by factor of safety. Shear yield strength divided by factor of safety. Shear yield strength is nothing but yield strength divided by 2 into factor of safety, which is nothing but under root 2P divided by S into L, right? And SYT is yield strength. SYT is yield strength, and SSY is shear yield strength. Shear yield strength, which is nothing but half of SYT, which is nothing but half of SYT that we have learned in theories of failure topic, right? Now from this equation, that is maximum shear stress is equal to SSY divided by factor of safety is equal to, from this equation, that is maximum shear stress, which is nothing but SSY divided by factor of safety is nothing but under root 2P divided by S into L. From this equation we can find P. From this equation we can find load carrying capacity. P is nothing but load carrying capacity. Therefore P is equal to, we can say SL into tau max divided by under root 2. And under root 2, if I solve this, I will get 0.707 S into L into tau max. Therefore P is equal to 0.707 into S into L into tau max. Now this formula is very much important, and on this formula we are going to see question. And GATE exam में इसी formula पे question आते हैं. In GATE examination, maximum time they are asking on questions on this formula. Where here this L is total length, my dear students. L is total length of weld. Total length of weld. S is plate thickness. S is plate thickness generally, which is given in the examination, right? And tau max is maximum shear stress. Maximum shear stress, which is nothing but SSY divided by factor of safety, right? Now, and P is load carrying capacity. P is applied load. What is the maximum load the plate can carry? Now let us go for the solution of first question. After learning this formula, we are going to solve the one by one questions. See, first question is, here you'll find first question, which is on fillet weld. Let us solve this question. See, this question was asked in GATE 2012 for 2 marks. GATE 2012 में 2 मार्क के लिए क्वेश्चन पूछा था. A fillet welded joint is subjected to transverse loading EF. See here, there is a transverse load EF, right? And here you can see weld here. At this location there is a welding. Welding is done. See, at this location as well as at this location also there is a welding, right? Here you will find welding at 2 locations, right? Now let us go to the again question. A fillet welded joint is subjected to transverse loading EF as shown in figure. Both legs of the fillet weld are 10 mm size. Both legs means leg size is given, that is S is given, my dear students. S is 10 mm. Leg size is given, S is equal to 10 mm. And the weld length is 30 mm. Length of the weld means this plus this. Total weld length is given. Here total weld length is given 30 mm. Right. For both welds, the length is 30 mm like this. Means total length is 30 mm. If the allowable shear stress of the weld is 94 MPa. Allowable shear stress means maximum shear stress. The meaning of allowable shear stress is nothing but maximum shear stress. That is maximum shear stress is given 94 MPa. 94 MPa, which is nothing but Newton per mm square. Considering the minimum throat thickness of weld, the maximum allowable transverse load in kilonewton is. What is the maximum load EF the plate can carry? Question here hai, right? Now let us solve this. Maximum shear stress is 94 MPa, that we know, right? Now let us solve this. Here I will zoom out this. Question is very simple, and there are 4 options: option A, option B, and option C, right? Option D. Now question is very simple, but they are asking in kilonewton. My dear students, the question we need to solve in kilonewton because the unit mentioned is kilonewton here. You can see here unit is kilonewton. Now let us solve this. Here weld size is given. Weld size or leg size or plate thickness is given 10 mm. Length of weld is given 30 mm. Right. Maximum shear stress is given 94 MPa. 94 MPa is nothing but 94 Newton per mm square. MPa is a unit of nothing but Newton per mm square. And they're asking what is F. Right. F, we have derived this formula, that is load carrying capacity is equal to 0.707 into S into L into tau max, where P is nothing but F. Here only P we have to replace with F. This formula just we have derived, and in Ekeeda application in recorded theory lectures, this derivation for this concept only I have taken 1 hour, and you can see these concepts properly, right? Therefore this P is equal to 0.707 into 10 into 30 into maximum shear stress is 94, right? Therefore put the values and tell me solution. My dear students, comment me your answer. Hello everyone. Everyone listen to me. Comment me your answer. Whatever may be the answer, comment me your answer. I am expecting answer from your side because everything I have written here. Dimensions we are using in Newton per mm square. Therefore, force will come in Newton. From this formula, you will get answer will be in Newton. But they are asking you to convert into kilonewton. Anybody solve this? Anyone solve this question? If yes, comment me. Anyone solve this answer? Tell me answer. Okay. किसी ने सॉल्व किया है तो आंसर बताओ. See, I think the answer will come 19937.4 Newton, and our target is to convert into kilonewton. Therefore, it will be 19.93 kilonewton. It will be 19.93 kilonewton, which is nothing but option C. Look at the options. You will find option C is the correct choice. Look at the options. You will find option C is the correct choice. For this question, option C is 19.93. Okay, solve next question. If you got the concept, then solve the next question. किसी को कोई doubt है? If anybody having any doubt, you can comment me. If any doubt, please comment me. Okay, then if no doubt, then go for next question. Here the next question you will see on your screen. It is on also fillet weld. This question is also on fillet weld. Now the question was asked in GATE 2006 for 2 marks. This question was asked in GATE 2006 for 2 marks. The question is, a 60 mm long, 6 mm thick fillet weld carries a steady load of 15 kilonewton. See here, the length of weld is given. Here the length of welding is given 60 mm. 60 mm long length. Then thickness means it is a thickness of plate, my dear students. Yes means thickness of plate means leg size. means leg size, which is nothing but 6 mm, and carries a load of 15 kilonewton, 15 kilonewton, load of 15 kilonewton, right? Which we can say as 15000 Newton. In Newton, this is the load. Then the shear strength of weld material is equal to shear strength of weld material means SSY is 200 MPa. Here SSY is given 200 MPa. 200 MPa. Then factor of safety is, they are asking what is factor of safety. For this question, what is factor of safety? And they have provided option A, option B, and option C, option D. There are 4 options. Now, my dear students, we have derived formula for this. That is P is equal to 0.707 into S into EL into maximum shear stress. Right. Now here P is given, S is given, EL is given. You can calculate maximum shear stress. Therefore, from this you can calculate maximum shear stress is equal to P divided by 0.707 into S into EL. Now let us find first maximum shear stress. If I find maximum shear stress, then as per maximum shear stress theory, we can find factor of safety also. Therefore, we can say this maximum shear stress is equal to P is nothing but 15,000 divided by 0.707 into S is 6, EL is 60, length is 60, right? Therefore, calculate this maximum shear stress. Whatever may be the maximum shear stress, calculate this. Whatever may be the maximum shear stress, calculate this. You will get this maximum shear stress is equal to, 58.9344 MPa, Newton per mm square. This will be the maximum shear stress. And as per maximum shear stress theory, that is tau max theory, we can use tau max theory. What is tau max theory? Maximum shear stress theory, my dear students. This maximum shear stress is equal to shear yield strength divided by factor of safety. Now use maximum shear stress theory. This maximum shear stress theory says that maximum shear stress is equal to SSY divided by factor of safety. Therefore, put the values. Now put the values here. If I use this theory, as per this theory, maximum shear stress is equal to SSY divided by factor of safety. Therefore, factor of safety will become SSY divided by maximum shear stress, which is nothing but SSY is given 200 in the given data, and maximum shear stress we have calculated 58.9344. From this, you will get factor of safety for this design. Now tell me, what is your answer for factor of safety? I think the answer will be 3.4. I think the answer will be 3.4. Therefore, look at the options. Option B is the correct choice. Here you can say option B, which is the number 3.4, is the correct choice. If you type option B, then only you will get correct full marks. For this answer, you will get 2 marks. And for any other answer, you will get minus 1/3 into 2. That is minus 2/3 marks. There is a negative marking for multiple choice question. It is a multiple choice question or not. For correct answer, you will get full 2 marks. For wrong answer, you will get minus 2/3 marks. There is a negative marking. Take care of this. Right. After this, let us solve the next question. If anybody having doubt, you can ask me. कमेंट बॉक्स आपके लिए अवेलेबल है. कमेंट करके आपका डाउट कोई भी होगा तो मुझे पूछो. चलो, after that we will go for next question. Now this next question was asked on butt weld. The question was asked on butt weld. Now let us understand first butt weld and then we will go for solution. Question is very simple. But first of all, understand butt weld. Butt weld is nothing but if plate thickness is very high. Let us say plate thickness is very high. Let us say this plate thickness is having some height h, or let us say h. Right. Now plates are kept at some distance. The two plates are kept at some distance apart. The two plates are kept at some distance apart from each other. एक दूसरे से दूर रखेंगे, जैसे कि for like this is a one plate, this is a first plate, and other plate is at some distance from the first plate. Right. Other plate is at some distance from the first plate. Like this. Other plate is at some distance from the first plate, like this. Right. There is a gap between first plate and second plate. And in this gap provided, we are doing welding like this. In this gap provided, we are providing welding. Means here welding is done like this. Welding is done like this. In this gap. Right. In this gap, welding is done. Now, my dear students, this extra material again called reinforcement. This extra material again called reinforcement, which is not considered for design. This extra material is not considered for design, right? Therefore, while designing along the length, let us say this is the length of weld. This is the length of weld, and area that considered. See, on this area, load is acting like this. Load P is acting like this. Now, for this area, that is area of length into h, right? The load is acting as a tangential, perpendicular. For this area of weld, load is acting as a perpendicular area, perpendicular force. Therefore, there will be tensile stress. Sigma T is equal to tensile stress is equal to P divided by H into L. Sigma T is equal to P divided by H into L. And this sigma T is nothing but considered with SYT divided by factor of 50 if it is a ductile material. But generally welding is, after welding, the portion, welded portion becomes brittle. Therefore, it is, we have to equate with SUT divided by factor of 50. Strength of material में पढ़ लोगे आप. For ductile material, for ductile material SYT is considered. For brittle material, SUT is considered. SUT is ultimate strength. Ultimate strength. In very first topic of strength of material, that is in stress strain diagram, you will learn this concept. For brittle material, we have to use SUT for the design, right? Therefore, here SUT is considered for welded portion because the welded portion becomes brittle. After welding, this becomes brittle. Therefore, SUT is considered, right? Now, this is a butt weld, and let us say by mistake, this is a plate. This is a plate and connected with another plate, right? Of, let us say, height of plate is, thickness of plate is h, I am considering, and by mistake, if I am doing welding, there is an undercut. जैसे कि, for example, let us say I am doing a welding and welding अंदर तक पहुंच ही नहीं पाया. Welding is like this. Let us say welding is like this, and this inner portion is not welded. Now at this portion, the filler metal is not reached. Therefore, let us say the filler metal is not reached for height h1. Let us say this is a height h1 where filler material is not reached, and the length of plate is L. The length of plate is L, right? Up to length L, the welding is done up to length L like this. For both plate, the length of plate is L. Like this, these are the plates. And welding is done up to the length L. Like this, there is a welding. And welding is not reached up to the, for total thickness. This is called undercut. This H1 is called undercut. This H1 is called undercut. Therefore, here length of weld is L. Therefore, area available here, area of welding portion. What I am saying, reinforcement is not considered, my dear students. Reinforcement is not considered. Therefore, you can see here extra material is not considered. Therefore, this area, blue hatching area, only we have to consider for length L. This blue color area only we have to consider for length L. Right. Now, therefore, area will become H, that is plate thickness, minus H1, which is nothing but undercut, into length of weld. This is the area. And here on this plate, the tensile force is acting. On this plate, the tensile force P is acting. Now this force P is acting as a tension. Therefore, there will be a sigma T, tensile stress, which is nothing but force divided by area, which is nothing but H minus H1 into L, where H is a plate thickness, H is a plate thickness, H1 is a undercut, and L is the length of weld, right? Which we have to equate with for maximum loading, which we have to equate with SSU divided by factor of 50. SUT, ultimate strength divided by factor of 50. Ultimate strength divided by factor of 50. This is a concept. This is a theory of failure. This is a Rankine theory. This is a Rankine theory of failure, right? That you have learned already in theories of failure topic. Now let us go for the design of butt weld. Now we will solve the numerical. This question was asked in GATE 2014. GATE 2014 for 2 marks in set 4. Now this question was asked on the concept of butt weld. Now let's solve this question. The question is, a butt weld joint is developed on steel plates having yield and ultimate tensile strength of, yield and ultimate means SYT is yield strength and SUT is ultimate strength. Now yield strength is given as 500 MPa, ultimate as 700 MPa. Yield is given 500 MPa, ultimate is given 700 MPa. Here you can see this is a yield and here it is a ultimate, right? Now come to the question. A butt weld joint is developed on a steel plates having yield and ultimate tensile strength of 500 MPa and 700 MPa respectively. The thickness of the plate is 8 mm. Thickness of the plate, we can say EH, 8 mm. Now here, see in this diagram, this thickness of plate is given. Thickness EH is given, my dear students. And H1 is undercut. H1 is undercut, right? Means this formula we have to use, right? Let us see the question. Go back to the question. Now, the thickness of plate is given 8 mm and width is 20 mm. Width means length of weld. Width of plate is nothing but length of weld, which is nothing but 20 mm. Which is nothing but 20 mm. Improper selection of welding parameters causes an undercut of 3 mm depth. Here undercut H1 is given. H1 is given undercut 3 mm. Causes an undercut of 3 mm depth along the weld. The maximum transverse tensile load in kilonewton carrying capacity developed in the weld is. Now, what is the maximum tensile load, or what is the maximum? What is the question? What is the maximum tensile load in kilonewton? They are asking what is the maximum tensile load P in kilonewton, right? This is the question. Now, here in the fill in the blanks, you have to type answer. In this bracket, you have to type answer. Whatever may be your answer, you have to type this, right? Now, let us solve this question. Here I will zoom out the diagram. I will zoom out the question so that we will get sufficient space. Let us say here, these are the 2 plates. This is a plate 1, right? And there is another plate. These 2 plates need to be welded. These 2 plates needs to be welded, and at this portion welding is done. But there is undercut also. There is undercut also, right? This plate thickness is EH and undercut is H1. This is H1. And welding is done for entire length. Here welding is done for entire width. Width is nothing but length of welding. Width is nothing but length of welding. Right. Therefore, we can say, and the load on this plate is P. And what is this load carrying capacity in kilonewton? This is the question. Therefore, we know that there will be tensile stress, which is nothing but load divided by area. Area is nothing but H minus H1 into width of the plate. Width is nothing but length also. Length of weld, we can say width of plate is length of weld, which is nothing but SUT divided by factor of 50. Which is nothing but SUT divided by factor of 50. And my dear students, if you read question carefully, they are asking what is the maximum transverse load. They are asking what is the maximum transverse load in kilonewton. Means for maximum load, factor of safety is equal to 1. That already I have explained in theories of failure topic. For maximum loadings, factor of safety becomes equal to 1. That already we have seen in theories of failure topic. Therefore, equation becomes sigma T is equal to P divided by H minus H1 into L is equal to SUT divided by 1. Now put the values. Whatever the given data, from given data, put the values. Therefore, we can say P divided by H is 8 minus H1 is 3 into length of weld is 20 is equal to SUT is given 700 divided by 1. Now from this P we will get 700 into 5 into 20. And my dear students, this answer will be in Newton. Don't forget, we are calculating in Newton, but question is to find in kilonewton, right? Therefore, answer is, tell me what is your answer? It is 70,000 Newton. Therefore, P is equal to 70 kilonewton. Therefore, in fill in the blanks, you have to type 70 kilonewton. In fill in the blanks, here, in this bracket, they are asking what is the maximum load, right, in kilonewton. Therefore, in this bracket, you have to type 70. Already unit is mentioned. Don't type again unit. Unit को फिर से type नहीं करना होता. They are asking in kilonewton. Already unit is mentioned in the question. So सिर्फ आपको provision होता है numerical value type करने के लिए. Therefore, type numerical value. Now here 70,000 Newton is correct, and 70 kilonewton is also correct. But if you type 70,000 here in this question, if you type 70,000, you will get 0 marks, because for fill in the blanks question there is no negative marking. And if you type 70 kilonewton, then you will get 2 marks. Right? For this, you will get 0 marks. For 70,000 answer, you will get 0 marks, and for 70 only. यूनिट को मारो बोलिए आप, क्वेश्चन में ही पूछा है, यूनिट बता दिया है उन्होंने, किलोमीटर में निकालना है. सो 70 किलोमीटर 70 टाइप करोगे तो ही आपको 2 मार्क मिलेंगे. अदरवाइज फॉर एनी अदर आंसर यू विल गेट 0 मार्क, बिकॉज फॉर सच टाइप ऑफ फिल इन द ब्लैंक क्वेश्चन देयर इज नो नेगेटिव मार्किंग. Okay, note down this. After this, let us go for the next question. Let us go for the next question. See, this question was asked in GATE 1987. See, the age of question is more than my age, right? Because I am from 89 and question is from 87. So, आपको बताने की कोशिश कर रहा हूँ. You have to solve all the previous year GATE questions. You have to solve each and every question from previous year examination, as well as you have to practice many questions from the reference book or any other standard workbook. Right. Now, let us go for the question. Theory question, very simple theory question. Weldments in a fabricated steel beams are designed for, number 1, bending stresses at the flange, B, shear stresses in transverse plane, C, combination of bending and shear, D, none of these, because in fabricated beams, welds do not get stressed. Now option D is 100% wrong. Option D is 100% wrong. अगर none of this होता, अगर ये none of this होता आंसर, तो welded joint पढ़ना ही क्यों होता हमें, right? Therefore, option D is 100% wrong because any component we have to design for any stress. None of this we cannot say. And on any component there is a normal stress which is called also direct bend, and there is a bending or normal stress, or there will be a shear stress. All the options are mentioned. Now let us consider, I will give you one welding. We have to imagine how many loads are there. Let us say there is a circular pipe. Let's say this is a circular pipe like this, right? And for this circular pipe, let's say I am considering this as a x-axis. Let's say this is a x-axis, and I am assuming vertical as a y-axis. Let's say this is a y-axis, right? And my target is to connect this circular pipe with the plate. Let us say we have one plate having YZ dimension. This is a plate. This is a plate. Right. And vertical is a y-axis. Vertical is a y-axis. Right. Now, our target is to join this pipe with this plate. And let us say the plate is having YZ dimension. This axis for the plate is Z axis. Right. Here, this axis is a X axis. And vertical axis is a Y axis. Y axis. These are the axes. Now, if I provide welding between the plate and pipe or rod, right, circular rod, here I will put a circular weld. Here at this location, I will put a circular weld. Now, let us say welding is done like this. This is the welding done, right? At this location, I will do the welding throughout the circumference, right? Welding is like this. We can say this is a welding. Welding. And let us say what I will do for this pipe, I will attach one more link like this. See, for this pipe, I will attach one more link like this. This is one more link is attached to the pipe. And on this link, if I apply force along y direction, force P along y direction, like this. Right. Now let us say this force P from point B, let us say here the point A and point B. AB is a rod. AB is a rod. From B, this force P is acting at distance, let us say this distance I am considering as a E, eccentricity. E, eccentricity. And distance between A and B, I am considering as a length of rod, which is L. Right. Now, can you imagine, because of this force P, this P into E is causing as a one type of movement which is trying to rotate the rod. Imagine करने की कोशिश करो. Try to imagine this case, my dear students. This force P into E, this moment is trying to rotate the rod. And as the rod is rotating, definitely this welding will also try to rotate. Correct or wrong? Means you have to imagine this is a strength of material concept. Here there is a moment which is nothing but torque is equal to T is equal to P into E. This torque is trying to rotate this rod AB. Correct or wrong? Right, 100% correct. And as well as now this P, if I want to put this P at B, इस लिंक को हटा के मैंने P को अगर B पे रख दिया, if I remove this extra link and if I put P directly on B, then I have to put this torque in whatever may be the direction, in clockwise direction, add B, right? Then only we can transfer like this. Right. This P I will remove from here and directly I will put on B. Directly I will put on B. But along with this force, there is a torque also, which is acting in torque is equal to P into E, which is acting in clockwise direction. Right. Now after this, go for welding. Welding location पे चलो. For observe for welded portion. Here, this P into L. Now this P into L is trying to bend the AB. This P into L in this diagram is trying to bend the AB link. Correct or wrong? P into L is acting as another moment which is trying to bend the rod like this. And if rod gets bent, therefore this P into L is moment, which is named M, which is P into L. Means it is a case of the welded portion is subjected to combined twisting and bending moment. Here it is a case of the welded portion is subjected to combined twisting and bending moment. Right. Therefore, we can say it is combined twisting and bending loading. Now, because of torque, there will be torsional shear stress. Now, as there is a torque, we can apply torsional equation T by J is equal to tau by R is equal to G theta by L. You have learned this equation in strength of material. Therefore, torsional shear stress is equal to T by J into R. Means it is subjected to shear also. It is subjected to shear stress. And because of this moment, it is subjected to M by I is equal to sigma B by Y. Means it is subjected to sigma B is equal to M by I into Y. From bending equation, this also you have learned in strength of material, bending stresses. The component is subjected to bending stress as well as torsional shear stress. Right. It is a bending stress. Bending stress. Therefore, the weld portion can be subjected to both shear, torsional shear as well as bending. Therefore, answer for this question. Now, tell me answer. Weldment in fabricated steel beams are designed for shear, combination of bending and shear. Right. Option C is 100% correct. There may be a shear stress also, there may be a bending stress also. Therefore, they are designed for both combination of bending and shear. Therefore, for this question, option C is correct. Okay, note down this. Now, if anybody having any doubt, you can ask me. With this question, we are concluding this lecture. तो अभी तक इस लेक्चर में कोई डाउट होगा तो पूछो मुझे. Hello everyone, I'm waiting for your doubts. If no doubt, in next 2 to 3 minutes, I will go offline. अभी तक अगर आपने Ekeeda का सब्सक्रिप्शन नहीं लिया है, subscribe for Ekeeda with promo code WADNE10. If you use this promo code on any subscription for Ekeeda, you will get 10% discount. This is my promo code so that you will get 10% discount for your any subscription. And Ekeeda app download करना मत भूलिएगा. Download Ekeeda app from the Play Store or App Store for both Android as well as Apple. iPhone, you will find this application. Okay, if nobody is having any doubt, then I will go offline. Chalo, bye bye. In next 1 minute I am going offline. 1 मिनट में अगर किसी का डाउट आता है तो उसका सोल्यूशन मिलेगा आपको, अदरवाइज यू हैव टू वेट फॉर नेक्स्ट लेक्चर.